Hi students, this is Shekhar sir. Hi students, this is Shekhar sir. Today I will explain about vertical circular motion. So did you see the vertical circular motion? So for example, if I will rotate like this, here I taken a ball of mass m. Here I rotate like this. So this is the example of a horizontal circular motion. Here the ball is moving in a horizontal circular motion. So for example, same ball, here I taken a body of mass m. So I rotated like this. I rotated like this. So this is the example of a vertical circular motion. Okay, now vertical circular motion. Here I taken a ball of mass, some for example 10 grams. I willed it. Okay, I tied to a string of rope length. Here it is the length of the rope. Here I taken as a R. R is the length of the rope. Okay, now after that I fixed one end here. I rotated like this. This is the vertical circular motion. Vertical circular motion. So to complete the vertical circular motion, we have to give minimum velocity for this body. For this body, then only the ball will complete vertical circular motion. If I will give only some velocity, what will happen? Here we will write. So here I am, so it will oscillate. I am giving only some velocity. It will not complete the vertical circular motion. Just it will oscillate like this. Okay, if I will give some velocity only, it will slag like this. It will slag like this. It will follow a parabola path. It follows a parabola path, but not a circular motion. So vertical circular motion means, so this is the vertical circular motion. So we have to give minimum velocity for the body to complete in a vertical circular motion. Let's we will learn. Look at here. Consider a body of mass m. Just I showed in the example. So tied at one end here. Here this is a body of mass m. So I tied to a one end here. One end of a string. Okay, one end of a string of length r. Here it is a r is the length of the string. R is the length of the string. And is willed in a vertical circle. So will means rotate in a vertical circle and fixing at the other end. Here it is I fixed at other end. So this is a vertical circular motion. So the purpose of this video to understand law of conservation of mechanical energy. So energy is the total energy remains constant at every point. The total energy remains constant at every point in a vertical circular motion. Next, to find the minimum velocity of a body at different positions. First thing is the vertical circular motion used to understand the law of conservation of mechanical energy. Next thing is that to find the tension at different places. This is the lowest position. This is the highest position. This is the horizontal position. So to find the tension at different places, to find the minimum velocity at different places, to understand the law of conservation of energy. Okay, now that is the purpose of this video. Okay, now next thing is the what is the daily life example of a vertical circular motion. Daily life examples are the roller coasters. So did you see the Wonderla? In a Wonderla, roller coaster is there. Roller coaster is there. It will move like this. It will move like this and it will move like this. So that is also a example of a vertical circular motion. Next thing is the gate Ferris wheels. So gained wheel also is a vertical circular motion. Next thing is a bucket of water. Okay, now when you take a small bucket, after that you fill with the water. When you rotate like this fastly, the water will not fall down because of the law of conservation of energy, as well as we have to give some minimum velocity of that body to continue moving the vertical circular motion. Okay, now in this video you are going to learn that concepts. Okay, now look at here. So here I taken a body of mass m. Here it is a body of mass m. Here I will represent with a bigger diagram here. I will represent with a bigger diagram. Larger diagram. For example, here for example, I have taken a body of mass m. This is a body of mass m. Okay, now this is a body of mass m. So I fixed it at one end. This is the center. I taken as a point to go. So the length of the string here it is I taken a body of mass m. Here it is a body of mass m. I tie to a string of length r. This is the total length of the string, that is the r. So I fixed it to one point. This is the that point at O. At O point I fixed the length of the string. Next I willed it like this. So I rotated like this. ఓకే, వెళ్ళి నేను ఇలా రొటేట్ చేస్తా ఉన్నా అనమాట. ఇలా రొటేట్ చేస్తున్నప్పుడు ద బాడీ విల్ మూవ్ ఫ్రమ్ here to here, here to here, here to here, like this. So this is the lowest position I taken as a A. A is the lowest position. So at the horizontal position, at this position I taken as a B. Horizontal position I taken as a B. Next at this position I taken as a C. C is the highest position. So D is this position I taken as a D. So when I rotated like this, when I rotate, I taken a body mass m. When I rotate like this, after some time, the body comes to this position. This is the position of a body of mass m after some time. Okay, now after some time, the position of a body at this point I taken as a point P. This point I taken as a point P. Next, here this body makes an angle with the initial position, that is theta is here. Okay, now making an angle with the initial position is theta. So at this position, the velocity of the body is like a tangent. When we draw the tangent at this point gives the velocity of the direction of the velocity at this point. So here the velocity of the body is like this. Here velocity I taken as a Vt. Vt is the velocity of a particle at any time, at any time interval. So here it is a Vt is the velocity of the particle. Next, look at here. When you close observe here, the tension is upward direction. The tension is acting this direction. So in this case, the mg is vertically acting downwards. This is the direction of the mg. Next, look at here. In this case, we have to resolve the mg into two components. One is here mg sin theta, this direction. Next, here it is mg cos theta is this is the direction of the mg cos theta. This is the direction of the mg cos theta. So why it is a cos theta? Because here theta is the making angle. Here it is also theta. Okay, now so if the component is okay, now angle is theta, then it will be the cos theta. Okay, now so ఎప్పుడైనా మనం వెక్టార్స్తో యాంగిల్ చేసేదాన్ని మనం దేంతో రిప్రజెంట్ చేస్తామంటే కాస్ థీటాతో రిజాల్వ్ చేసుకుంటాం అనమాట. సో కాస్ థీటా అనేది రిప్రజెంట్ చేయాలి. So here mg is resolved into two components. One is mg sin theta, here it is mg cos theta. Okay, now here at this position we have to find out the velocity of the particle at this point to P. So to find the velocity of the particle at this point to P, so we have to apply the law of conservation of mechanical energy. Law of conservation of mechanical energy. Law of conservation of mechanical energy. What does mean law of conservation of mechanical energy? Law of conservation of mechanical energy says that the total energy remains constant throughout the system. Okay, now. So here, total energy at point to A, we can take it as the total energy at point A equal to total energy at point to P. Total energy point at P. So here total energy is the sum of the mechanical, sum of the potential energy plus kinetic energy equal to at point A equal to potential energy at point P plus potential energy, kinetic energy at point P. Okay, now sum of total energy remains constant. So total energy means it is a mechanical energy, sum of the mechanical energy plus kinetic energy. Look at here, at this position, at point A, I taken as a reference point. So this is the A point is the reference point. So height is a 0. So potential energy equal to mg into 0 plus 1 by 2 mv1 square. Here I taken as a velocity v1. So which is equal to mg here. Here this is the height of the particle based on the from the reference point. From the reference point, this is the height of the particle. Here I taken as a height h. Total is a r. Total length of the string is a r. Here to here is a h. Here to here is a h. What does mean this here remaining portion is a r minus h. Remaining portion is a r minus h. When you apply the cos theta here, cos theta equal to I adjacent side by r minus h by hypotenuse, that is a r. So when you solve it here, r cos theta equal to r minus h. So here we need to find the h equal to r minus r cos theta, which is equal to h is equal to, when you take r common, it is a 1 minus cos theta. H equal to 1 minus cos theta. This is the height. This is the height value is the h equal to r into 1 minus cos theta. So this is the height from the base, from the reference point. This is the height of the body. But here we need to find this height. This height is the total. Total is the length of the string r. So here it is a r minus h. Here I taken as a point Q from the triangle OQP. Here OQ is the adjacent side and OP is the hypotenuse. So cos theta equal to adjacent side by hypotenuse. So from this triangle you are getting height equal to h equal to r into 1 minus cos theta. Now put here mgh plus kinetic energy at point P equal to 1 by 2 mvt square. mvt square. Put in the formula here. 1 by 2 mv1 square equal to mg into h means 1 minus, h means there r into 1 minus cos theta plus 1 by 2 m into vt square. When you take LCM and cancel this, m by 2 is taken as a common. v1 square equal to 2 mgr 1 minus cos theta plus 1 minus cos theta plus vt square. Here when you take common, here also m by 2 when you take common 2gr into 1 minus cos theta equal to cos theta into vt square by 2. m by 2 here, m by 2 cancel. So here Vt square, we need to find the Vt square. So here Vt equal to root of, direct step I will write, root of V1 square minus 2gr 1 minus cos theta. This is the velocity of the body. Thank you. So this is the Vt is the velocity of the body. Vt is the velocity of the body at any place. Okay, in a vertical circular motion. To find the velocity, here Vt equal to root of V1 square minus 2gr into 1 minus cos theta. So, for example, here I need to find the velocity of the particle at this point to B. So, here B is I need to find the velocity of point to B. So, at point to B, here theta equal to how much? Theta equal to 90 degrees. Now, put in the formula. Here, when you put here, Vt equal to root of V1 square minus 2gr cos 90 is a 0. So, 2gr into 1, which is equal to 2gr. So, velocity of that point B, or velocity horizontal position Vb equal to V root V1 square minus 2gr. Root V1 square minus 2gr. Next, to find the velocity at highest position. What is here? At highest position, theta equal to 180 degrees. At this horizontal position, theta equal to 90 degrees. Now put in the formula here. Here, velocity at point C equal to V1 square minus 2gr into 1 minus cos 180. Cos 180 is a minus 1. Cos 180 is a minus 1. So, when you solve it, there, here, 1 minus 1 equal to 0. So, 0 into 2gr equal to 0. So, at say C, at highest position, velocity Vc equal to, it will become equal to V1. Velocity equal to V1. So, here, at the lowest position, this is the lowest position, theta equal to 0 degrees. At A position, theta equal to, when you put value 0 degrees, then velocity point at point A equal to root of V1 square here, it will become here 1 minus of minus 1 plus 1, 2 into 2 minus 4. So here velocity at the topmost point equal to V1 square minus 4gr. V1 square minus 4gr. This is the velocity at point C. Next, velocity at point V equal to V1 square minus 2gr into 1 minus cos 0. Cos 0 is the 1. 1 minus 1, 0. So at the lowest position, velocity Va equal to V1. Velocity Va equal to V1. So this is to find the velocity at any point in the vertical circular motion. So to apply the law of conservation of energy, we need to apply the law of conservation of energy. So law of conservation of mechanical energy means the total energy remains at constant throughout the circular motion. So again, total energy point at point A equal to total energy point at P point. Okay, now this point total energy at any point in the system is equal. So total energy means sum of the potential energy plus kinetic energy equal to sum of the potential energy plus kinetic energy at point P. So potential energy formula mgh. So here it is I taken as a reference point. So height is a 0. 1 by 2 m v1 square equal to mgh plus 1 by 2 m vt square. So 1 by 2 mv1 square equal to mgh. Here based on the triangle here, height equal to r into 1 minus cos theta. So mg r into 1 minus cos theta plus 1 by 2 m vt square. So when you solve here, you will get a velocity at any point vt equal to root v1 square minus 2gr into 1 minus cos theta, minus 2gr into 1 minus cos theta. This is the velocity of a particle at point P. At point P, making some angle theta with the initial position. So when you put the value of theta here in this formula, you will get a velocity at that point. For example, here I need to find the velocity at this point. So this horizontal position, ఈ horizontal position దగ్గర theta value is 90 degrees. When you put in the cos theta place, cos 90 value, you will get velocity at point B point equal to root v1 square minus 2gr. Next, this is the value of theta equal to 0. When you put theta equal to 0 here, you will get a velocity at point A equal to Va equal to V1. Next, at this position to find the velocity, we need to find the cos theta equal to 180. So when you put the cos 180 here, you will get velocity at this point C equal to root V1 square minus 4gr. Okay, now this is to find the velocity at any point in a vertical circular path, vertical circular motion. Next thing is find the tension. Next thing is find the tension at point lowest position as well as the highest position as well as the horizontal position. What is the value of tension at lowest position, highest position? Here we need to find out. Look at here. Here also we have to apply the free body diagram rule. So here tension is acting this direction. Tension is acting this direction at point P. When you apply free body diagram according to Newton's second law, when you apply free body diagram for the point at point P, at point P, tension is acting this direction, mg cos theta acting this direction. So in this case, tension is greater than the mg cos theta. So here T minus mg cos theta, which provides the centripetal force, mv square by r. Okay, now tension minus here tension force is greater than the mg cos theta. So that's why the body is moving in a vertical circular motion. So tension minus mg cos theta, which is equal to the centripetal force, which is equal to the mv square by r. Okay, now here tension T equal to mg cos theta plus mv square by r. This is the tension at point P. Tension at point P. Simple. When you find the tension at, if you want to find the tension at point A, simple, we have to put the value of theta. So at position at point A, ఏ దగ్గర మనకు టెన్షన్ కావాలి, ఏ దగ్గర టెన్షన్ కావాలంటే we have to replace the theta value how much here, 0 degrees here. So at point A, theta equal to 0. When you put here 0 value, then the tension will become tension T equal to mg plus mv square by r. Next, when if you want to find the tension at point B, at horizontal position, if you want to find the tension here at point B, theta, what is the value of theta? Here this position, theta equal to 90 degrees. Theta equal to 90 degrees. Put in the formula T equal to mg cos 90 degrees plus mv square by r. So which is equal to tension equal to mv square by r. At point B, tension is provided by, which is equal to the centripetal force mv square by r. To find the tension at point C. Okay, now this is the maximum tension. When you if you find the put the value of at position C, at C, theta value equal to 180 degrees. Put there, you will get here at position tension equal to mv square minus mv square by r minus mg. Tension equal to mv square by r minus mg. This is the minimum tension. This is the minimum tension at highest position. Highest position దగ్గర minimum tension ఉంటుంది. That is the minimum tension at point C. Here I see I taken as a point as a highest point. At highest point tension is a minimum mv square minus how much minimum mv square by r minus mg. Next at lowest position tension is the maximum. Tension is the maximum. How much mv square by r plus mg. mv square by r plus mg. So when you subtract, okay now, when you subtract maximum tension minus minimum tension, you will get 6 mg. How much equal to it is? You will get 6 mg. Next, maximum tension minus minimum tension equal to V1 square plus Rg by V2 square minus Rg. V2 square minus Rg. Next thing is a very important thing is this is the how we can find the tension at any place in a vertical circular motion. Vertical circular motion లో టెన్షన్ అనేది ఫైండ్ అవుట్ చేయాలంటే we have to apply the free body diagram rules. So first thing at point P దగ్గర మనం ఫ్రీ బాడీ డయాగ్రామ్ రూల్ అప్లై చేయాలి. సో ఇయర్ టెన్షన్ అనేది గ్రేటర్ దెన్ ద ఎంజీ కాస్టెడ్. సో టీ మైనస్ ఎంజీ కాస్టెడ్ విచ్ ఈక్వల్ టు దేనికి ఈక్వల్ అవుతుంది అంటే బాడీ భూగానికి యాక్ట్ చేసే సెంట్రిపెటల్ ఫోర్స్ కి ఈక్వల్ అవుతుంది. సో టెన్షన్ మైనస్ ఎంజీ కాస్టీటా ఈక్వల్ టు ఎంబీ స్క్వేర్ బై ఆర్. సో ఇయర్ టెన్షన్ ఈక్వల్ టు ఎంజీ కాస్టీటా ప్లస్ ఎంబీ స్క్వేర్ బై ఆర్. ఈ ఫార్ములా చాలా ఇంపార్టెంట్. ఇక్కడ వరకు మీకు అర్థమైంది అనుకో. వెన్ యూ పుట్ ద వాల్యూ ఆఫ్ థీటా, కాస్ థీటా ప్లేస్ లో కాస్ 0 పెట్టినాం, మాక్సిమం టెన్షన్ కాస్ 90 పెట్టినాం, టెన్షన్ ఈక్వల్ టు ఎంబీ స్క్వేర్ బై ఆర్. నెక్స్ట్ ఎట్ దిస్ పొజిషన్ ఇఫ్ యూ వాంట్ ఫైండ్ ద టెన్షన్, ఈ పాయింట్ దగ్గర టెన్షన్ కావాలంటే ఏం చేయాలి? థీటా ఈక్వల్ టు 180 degrees. సింపుల్ గా కాస్ థీటా ప్లేస్ లో థీటా వాల్యూ 0 పెడితే టెన్షన్ వస్తుంది, 90 పెడితే టెన్షన్ ఈ పాయింట్ దగ్గర టెన్షన్ వస్తుంది. When you put the value of here theta equal to 180 degrees, you will get tension there. So maximum tension mv square by r plus mg. Minimum tension at the highest position దగ్గర tension అనేది తక్కువ ఉంటుంది, mv square by r minus mg. Next thing is a very important thing, critical velocity. What does mean critical velocity? Okay, now critical velocity means we have to give the minimum velocity. We have to give the minimum velocity to a body to complete the circular motion. To complete the circle, we have to give the minimum velocity. So what does mean critical velocity? What does mean critical velocity? Critical velocity, to complete the vertical circular motion, we have to give minimum velocity of a body to a body. సో ఇలా వర్టికల్ సర్క్యులర్ మోషన్ లో బాడీ అనేది రొటేట్ అవ్వాలంటే, ఈ బాడీ అనేది ఇట్లా కంప్లీట్ గా ఇట్లా రొటేట్ అవ్వాలంటే ఓకేనా, ఈ బాల్ కు మనం మినిమం వెలాసిటీ ఇవ్వాలి. అది ఎంత ఇవ్వాలి అంటే ఎట్ ద హైయెస్ట్ పొజిషన్, ఈ పొజిషన్ దగ్గర టెన్షన్ మస్ట్ బి గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు 0. టెన్షన్ అనేది ఇట్ మస్ట్ బి గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు 0. టెన్షన్ అనేది ఈక్వల్ టు 0 అయి ఉండాలి, లేకపోతే గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు 0 అయి ఉండాలి. సో లుక్ ఎట్ హియర్, టెన్షన్ ఎట్ హైయెస్ట్ పొజిషన్ ఇస్ mv square by r minus mg must be greater than or equal to 0. So when you look at here, mv square by r greater than or equal to mg, m get cancelled, v square greater than or equal to rg. Here V is greater than or equal to root RG. V is greater than or equal to root RG. To complete the vertical circular motion, we have to give the minimum velocity to a body. That minimum velocity is called critical velocity. To complete the looping loop, okay, now to complete the vertical circular motion, we have to give the minimum velocity of to a body. ఒక బాడీకి మనం ఏం చేయాలంటే మినిమం వెలాసిటీ ఇవ్వాలి. ఆ మినిమం వెలాసిటీ ఇస్తే బాడీ అనేది కంప్లీట్ గా వర్టికల్ సర్క్యులర్ మోషన్ లో రివాల్వ్ అవుతుంది. సో ఎంత ఎంత ఇవ్వాలంటే v ఈక్వల్ టు గ్రేటర్ దెన్ ఆర్జీ. v ఈక్వల్ టు ఆర్జీ అయినా కూడా బాడీ అనేది కంప్లీట్ గా రొటేషన్ గా కంప్లీట్ సర్కిల్ చేస్తుంది. v గ్రేటర్ దెన్ ఆర్జీ, v గ్రేటర్ దెన్ రూట్ ఆర్జీ అయినా కూడా ఆ బాడీ అనేది కంప్లీట్ గా మనకు సర్కిల్ అనేది చేస్తుంది. సో v ఈక్వల్ టు రూట్ ఆర్జీ ఇస్ కాల్డ్ as critical velocity. ఇస్ కాల్డ్ as critical velocity. సో ఈ క్రిటికల్ వెలాసిటీ ఇస్తే బాడీ అనేది కంప్లీట్ గా సర్క్యులర్ పాత్ లో రొటేట్ అవుతుంది. ఓకేనా? వాట్ విల్ హ్యాపెన్ if you are not giving the critical, if the velocity is less than root rg, velocity is we are giving the velocity less than the root rg, what will happen? Okay, now the body will follow a parabolic path. ఇట్లా బాడీ అనేది ఇలా వస్తుంది అనమాట. will follow a parabolic path. It will not complete the circle. It is slacks అంటే బాడీ అనేది ఫర్ ఎగ్జాంపుల్ ఇక్కడ నుంచి ఇట్లా వస్తుంటది అనమాట. బాడీ అనేది పై వరకు కంప్లీట్ గా వెళ్ళకుండా ఇట్లా బాడీ అనేది పారాబోలిక్ పాత్ లాగా ఇట్లా పారాబోలిక్ పాత్ లాగా ఇట్లా కిందికి ఇట్లా వస్తుంది అనమాట. ఇట్ ఈస్ లైక్ ఏ స్లాకెన్స్, ఇట్లా వంగుతూ వస్తుంది అనమాట. బాడీ బ్లాక్ అనేది ఇట్లా వంగుతూ వస్తుంది అనమాట. ద వెలాసిటీ మనం ఆ బాడీకి వెలాసిటీ అనేది తక్కువ ఇస్తే ఇట్లా వంగుతూ వస్తుంది అనమాట. ఎట్ హైయెస్ట్ పొజిషన్ దగ్గర వెలాసిటీ ఎంత ఉండాలంటే రూట్ ఆర్జీ ఉండాలి. ఎట్ లోయెస్ట్ పొజిషన్ దగ్గర ఫ్రమ్ దిస్ ఈక్వేషన్ వీ కెన్ ఫైండ్ అవుట్ ఎట్ లోయెస్ట్ పొజిషన్ దగ్గర వెలాసిటీ అనేది ఎంత ఉండాలంటే హియర్ హౌ మచ్ వెలాసిటీ అంటే లోయెస్ట్ పొజిషన్ దగ్గర రూట్ 5gr ఉండాలి. This is the minimum velocity at lowest position, root 5gr. Lowest position దగ్గర బాడీకి ఎంత వెలాసిటీ ఉండాలంటే రూట్ 5gr. at horizontal position దగ్గర బాడీకి ఎంత ఉండాలంటే critical velocity రూట్ 3gr. If the velocity at lowest position less than root 5gr, what will happen? దీనికంటే తక్కువగా ఉంది. ఏమవుతుందంటే బాడీ విల్ నాట్ కంప్లీట్ ఏ వర్టికల్ సర్క్యులర్ మోషన్. బాడీ అనేది వర్టికల్ సర్క్యులర్ మోషన్ ను కంప్లీట్ చేయదు. దీనికంటే తక్కువ ఉంటే కంప్లీట్ చేయదు. ఎట్ లోయెస్ట్ పొజిషన్. హైయెస్ట్ పొజిషన్ దగ్గరనేమో క్రిటికల్ వెలాసిటీ రూట్ 2gr. ఓకే, హియర్ అట్ హారిజాంటల్ పొజిషన్ దగ్గర క్రిటికల్ వెలాసిటీ రూట్ 3gr. 3gr కంటే తక్కువ ఉంటే అట్ హారిజాంటల్ పొజిషన్ ద బాడీ అనేది స్లాక్ ఇట్లా వంగుతూ వస్తుంది అనమాట. ఇట్లా వంగుతూ వస్తుంది. ఇట్ విల్ నాట్ కంప్లీట్ ఏ సర్కిల్. ఓకేనా? This is about vertical circular motion. So vertical circular motion is based on the law of conservation of mechanical energy. The energy at any point, for example, total energy at point A equal to total energy point at C. Total energy point at A equal to total energy point at B. Again, watch this video. You can understand better. After watching this video, I added some worksheets. You can solve it and put the answers in the comment box. Please like it, subscribe it, share to your friends. Thank you.